In this video, I'm going to discuss IUPAC names of carboxylic acids and derivatives of carboxylic acids. So in this, first we need to identify the functional group. Accordingly, we have to give the systematic name. In the first example, it is clear carboxylic acid and there are only two carbon atoms, no prefix. Root word is eth, primary suffix oic acid. Ethanoic acid. It is a chain terminating functional group. Need not to indicate the position. So whenever you are not indicating the position, ethane, E should be dropped. E should be dropped, and here again there is carboxylic acid functional group. Only one carbon atom is present, and this is methanoic acid. Next, three carbon atoms. It is a chain terminating functional group, need not to indicate the position. So that is a propanoic acid. Or you can also write like this, no problem. Propane, 1 oic acid. Always it is at first position. 1, 2, 3, 4. So the name of this compound is butanoic acid. Butane oic acid. 1, 2, 3, 4, 5, and this is pentanoic acid. Next we have totally 6 carbon atoms. Root word, primary suffix, secondary suffix, hexanoic acid. And here we have two functional groups. One is carboxylic acid, another one is double bond. So carboxylic acid gets more priority. Therefore, here this is root word prop. Between 2 and 3 there is double bond prop to in oic acid. Whenever single bond and CC single bond and CC double bond both are present, we indicate primary suffix of only CC double bond. So here this is the first carbon, this is second carbon, third and fourth, but here there is branch, that is methoxy, located at a second place, and this is 2-methoxy. Root word but, primary suffix and secondary suffix, 2-methoxybutanoic acid. 1, 2, 3, 4, 5. So this is a 3-bromo pentanoic acid. First carbon, second, third, fourth, fifth and sixth. Prefix is a chloro, so that is at the fourth place, 4-chloro hexanoic acid. Most importantly, here chain terminating functional group, that is COOH, is directly attached to the ring system. This carbon cannot be taken into the longest chain. You have to recollect the rules properly. So this is the first carbon. Of course, second, third, fourth, fifth and sixth, in any direction you can move because there are no other branches. First, you don't forget it is a cyclic compound. Therefore, it is a cyclohexane. At the first position, there is carboxylic acid. You need to understand the difference. Till here we said oic acid. Instead of carboxylic acid, we said oic acid because C of COOH was in the longest chain. But now C of COOH is not in the longest chain. Therefore, we are using special suffix, that is carboxylic acid. And the next one, this is benzene carboxylic acid. Benzoic acid, earlier it was a common name, but IUPAC accepted a benzoic acid. Therefore, you can say benzoic acid also. And here there are two carboxylic acid groups. 1, 2, 3, 4, 5, 6, and here this is benzene 1, comma 2 dicarboxylic acid. These are some examples of carboxylic acids. Now let us take the next functional group. Here it is very clear, acid halide. So this is first carbon, second carbon. It is also chain terminating functional group. So this is eth, ane, oil chloride. Oil chloride. First carbon, second, third, fourth, fifth. There is a branch at a third place. Therefore, it is a 3-methyl root word pent ane oil bromide. It is a chain terminating functional group, need not to indicate the position. Let us proceed with the next example. If you carefully observe, here the functional group is acid halide. Whenever chain terminating functional group is directly attached to the ring system, this carbon cannot be taken into the longest chain. Due to that particular reason, we have to use special suffixes. After applying all those rules properly, if you give its name, so this will be the first carbon. Of course, there are no prefixes. Only to count the number of carbons, I just gave numbers like 1 to 5. There is no prefix in this. There is no branch in this. Only primary prefix, that is cyclo. So this is a cyclo, root word pent, primary suffix ane. But most importantly, we have to say 1 carbonyl chloride. If you say oil chloride, that is wrong. Oil chloride or oil bromide, that is correct when carbon of that COX is taken into the longest chain. But this carbon could not be adjusted in the longest chain. Therefore, we are using special suffix, that is carbonyl chloride. And the next one is ester. Even while naming esters, alkyl group attached to oxygen should be indicated first. So here this is the first carbon, this is the second carbon, and this is a branch. So the name of this compound is ethyl, root word eth, ane, ethanoate, oate, chain terminating functional group, that is. Next so here longest chain we have to select first carbon, second carbon, third carbon, fourth carbon. In fact, this is the longest chain. This is one branch attached to carbon. This is one branch that is attached to oxygen. Don't worry, here this part is named in the form of oate, oate. So we have to indicate the name of this, name of this, name of this, I mean longest chain and functional group. But if you can recollect one rule which was discussed earlier under miscellaneous rules, while naming esters, irrespective of alphabetical order, alkyl group attached to oxygen should be indicated first. Therefore, you have to start the name by saying methyl, then you have to say 3-bromo, root word but, primary suffix ane, secondary suffix oate. Again, this is ester. This is first carbon, second carbon, third carbon, and this is branch attached to oxygen. The name of that group is name of that branch is phenyl. Therefore, it is phenyl, root word prop, ane, oate, propanoate. Again, here if you see, this carbon cannot be taken into the longest chain. So here special suffix we have to use. This is the first carbon. Of course, there are no branches on carbon chain, but there is one branch that is attached to oxygen. So the name is ethyl. Don't forget it is a cyclic system. Cyclohexane, not O8. You have to say carboxylate. Special suffix we have to use. Carboxylate. If it is normal, O8, but here you have to say carboxylate. Again, here we have ester functional group, and here this is longest chain, and this is the branch. This is the branch, and here that is attached to oxygen. So this is a complex substituent. We can say that is phenyl methyl methyl ethanoate. Instead of this, in fact, complex substituent name should be enclosed in brackets. Instead of that, we can simply say benzyl ethanoate, benzyl ethanoate. And the next one, so here this is the first carbon, this is the second carbon, and here this is the branch. Actually it is a complex alkyl group. If you can recollect how to name complex alkyl group, here point of attachment. So here this is the first carbon, this is the second carbon, this is third, and this is fourth, and this is a substituent. While naming complex substituents, the entire name should be enclosed in brackets. So at the third position there is methyl group, therefore it is 3 methyl. Totally there are 4 carbon atoms, therefore it is butyl complex substituent. Root word ethanoate. And the next example, 1 2 3 4, and this is methyl group, therefore it is methyl butanoate. Methyl butanoate. Next functional group is amide functional group. It is a primary amide because nitrogen is attached to only one carbon directly. Here if we have alkyl groups, then it is a secondary and tertiary amide. So 2 carbon atoms, root word ethanamide. First carbon, second, third, fourth. 4 carbon chain. At the fourth carbon there is chlorine. 4 chloro butanamide. And here this is a chain terminating functional group. Carbon is directly attached to the ring system. This carbon cannot be adjusted in root word, so we have to use a special suffix. Special suffix in case of amides, that is carboxamide. So this is benzene carboxamide, not amide, carboxamide. Special suffixes you have to use. And it is a secondary amide, first carbon, second carbon, third carbon, and here this group is cyclohexyl, but that is attached to nitrogen, not carbon chain. N cyclohexyl, root word propanamide, secondary amide, that is basically. Now this is a tertiary amide because this nitrogen, here alkyl group, and here it is a C double bond O. This is a tertiary amide. In case of longest chain, 1 2 3 4 5, this is the branch ethyl group, this is the branch methyl group. They are attached to nitrogen. So this is N methyl pent ane amide, pentanamide. Again, this is ethyl group. This is ethyl group. It is tertiary amide. First carbon, second carbon, third carbon, fourth carbon. N comma N diethyl butanamide. You have ester functional group here. This is first carbon, second carbon, third carbon, fourth carbon. And in fact, this is a isobutyl group. You can say iso is accepted by IUPAC. So this is isobutyl butanoate. Isobutyl group, even one we can give one more name. So here this is 1, 2, 3. At second position there is methyl group, complex substituent. So that is 2 methyl. Here it is 3 carbons, propyl. Instead of isobutyl you can use, and butanoate is the same. And again special suffix we have to use, and this is a cyclopentane carboxylic acid, not oic acid, carboxylic acid, special suffix. Tertiary amide, first carbon, second, third, fourth, fifth, and sixth. Methyl group, N comma N dimethyl hexanamide. A primary amide. So this is propanamide. 1, 2, 3, 4, 5, 6. This is 5-methyl hexanoic acid. 5-methyl hexanoic acid. 1, 2, 3, 4, 5. Pentanoyl chloride. Now, this is acid anhydride. Oic anhydride we have to use. First, what you need to do is you just count the number of carbon atoms. 1, 2, 3. So 3 carbons. Therefore, we have to use this part as propanoic. 1, 2, 3. So that is also propanoic. But don't say dipropanoic. Just you have to indicate. However, this is understood in case of acid anhydrides. In case of acid anhydrides, oxygen is attached to two alkanoic groups. So when same groups are repeated here, don't say dipropanoic. So this is propanoic anhydride. Now, if you see, this is 2 carbons, therefore it is ethanoic, and this is benzoic acid. This is benzoic, and this is ethanoic. We have to follow alphabetical order. Therefore, the name of this compound is benzoic ethanoic anhydride. And again, this is acid anhydride. So here we have one carbon, here one carbon, here one carbon. Both are ethanoic. Both are ethanoic acids. Both are coming from ethanoic acids. So therefore, it is ethanoic anhydride. But don't say diethanoic. And here, this is again benzoic. This is also benzoic. Therefore, it is benzoic anhydride. Now, let us observe this. In case of the first one, 1, 2, 3, propanoic with a branch, methyl propanoic. Of course, 1, 2. 2-methyl propanoic. We can say that is no issue, that is 2-methyl propanoic. 1, 2, 3 propanoic, there is no branch. Here the name is methyl propanoic and this is just propanoic. Alphabetical order we have to follow. Therefore, that is 2-methyl propanoic. Another one is just propanoic anhydride. After seeing this, you will get the idea. This is anhydride. So you have to write oxygen. One side is a propanoic group. Another side is not a simple propanoic, that is 2-methyl propanoic. So this is about carboxylic acids and derivatives. Thank you very much.